All right, guys. So I hope you're all doing well. If you have any questions on the last homework, please let me know through Edsby. Any questions that you have, I'll be more than happy to make up a quick little video and post it for you so you can see step by step. I do still have some questions that were unanswered from yesterday, and that's because my day for you guys on office hours. So again, I need you to pay attention and read the instructions, but your office hours are on day one, okay, in the afternoon. So I don't mind if you ask me the question. If I have extra time, I will answer it. Generally, on day two, I do not because I have to prepare and make videos for not only you guys, but also for Calc BC, and that's BC is a little more involved. So I don't have as much time on day two. All right, so I will get to your questions that were asked today, tomorrow morning. All right, so let's talk about section 6.6, the trig form of a complex number. This is going to be short and sweet. It's not difficult at all, provided you know your unit circle. So let's get into this, all right, and then you'll do some homework tomorrow after you watch the video. So the standard form of a complex number is z equals a plus bi, where a is the real part and b is the imaginary unit, right? Okay. The trig form of a complex number looks like this, okay? Z equals to R times the quantity cos theta plus I sine theta. And in upper math, we write it as R cis theta. So for shorthand notation, now I don't know if WebAssign will take this at this level of math. So if you try to enter this, for those of you who like the shorthand notation, you can use it in your work in your notebook, but I'm not sure that WebAssign would recognize it for a pre-calculus level. But I don't mind if you write it like that. So what this means is R times cosine times I sine, or sorry, cosine plus I sine theta. Okay, it means this thing above it. It's just in shorthand notation. And another thing is that trig form is also called polar form. So just keep that in mind. The polar form of a complex number means the same exact thing as the trig form of a complex number. What's really important is that you know these things, that A is equal to R cosine theta, B is equal to R sine theta, R is the magnitude of A squared plus B squared, and that's called the modulus of Z, and the tangent of theta is B over A, and theta is called the argument of Z, okay? So you need to know these little formulas right here. You're going to use them constantly when you're writing back and forth. Okay, so what you're going to do is the following. You're going to write the standard form of a complex number to trig form. So in other words, you're going to go from here to here. And then you're going to go backwards. You're going to write the trig form to standard form, meaning you're going to be given this and you're going to be asked to reproduce it in standard form. What I want to say is that it's really important that you plot the complex number. And the reason why is because of this tangent here. You need to know what quadrant the tangent's in because the tangent changes sign depending on what quadrant it's in. And sort of the sine and the cosine. So it's really important that you orient yourself as to the quadrant, and it takes 2 seconds to plot complex number, which can then be connected and drawn as a position vector. Anyway, here are the little formulas again that I just talked about. And what we're going to do is we're going to take a nice simple problem, a standard form of a complex number, -2 minus 2 root 3 times I, and we want to write it in trig form. So here's the steps that I suggest. Number 1, you plot the complex number. So we start at the origin, we go over 2 in the real direction and down to root 3 in the imaginary direction. Remember, this is the real axis and this is the imaginary axis. And we plot the point. And then we can connect it with a directed line segment, so we have a position vector. And that means that this point, which is -2 comma -2 root 3, can be written as the components of a vector, right? And that's good. Why? Because R is A squared plus B squared. So, I mean, you know this is A and this is B, so you could leave it like that. So let's find R. If I plug in my A and square it and my B and square it, -2 squared is going to give me a +4. Any negative number squared is going to give you a positive result. Plus, here's where you're going to be careful. You have to square the outer number and, of course, the square root. So -2 times -2 is 4. Root 3 times root 3 is 3. Okay, that's 12 plus 4 or 16, and we know that the square root of 16 is 4. So we've got our r. Okay, we also know we're in quadrant 3. The tangent is positive in quadrant 3. The sine and the cosine are both negative in quadrant 3. Now we have to find our theta, our argument. Okay, we found the modulus, we've got to find the argument. So we say the tangent of theta is b over a. Well, I'm plugging in negative 2 root 3 for b and negative 2 for a. The negative 2's cancel, and I'm left with root 3, and I have to remember from my unit circle when the tangent equals root 3. Well, the tangent equals root 3 if you think about quadrant 1 at pi over 3. But we're in quadrant 3. So to get a quadrant 3 angle or argument, what I have to do is I have to add pi over 3 to pi. So to get from here to here, it's pi plus pi over 3, which is 4 pi over 3. Once I have my argument, now I can substitute my r, my theta, or my argument, into this formula right here, or into the shorthand formula. So r was 4, so I plugged in a 4. Notice these angles will always be the same, right? 4 pi over 3. So it's 4 times the quantity cosine 4 pi over 3 plus I sine 4 pi over 3. In cis notation, it's z is equal to 4 cis 4 pi over 3. And again, cis just means cosine plus I sine. It's just a shorthand notation. Here's another one. We want to write 6 minus 6i in trig form. I'm going to plot the number. I start at the origin. I go over 6, down 6, plot the point, connect it with the directed line segment. I have the component vector 6, negative 6. I know what a and b are. I plug it into my formula for modulus. 6 squared plus negative 6 squared is just 36 plus 36, or 36 times 2. And that's nice because the square root of 36 is 6, so that comes out of the house, and root 2 stays in the house. So I have my r, my modulus. Then I have to find my theta. It's b over a, so it's negative 6 over 6, which is negative 1. Now again, if you forget about the negative sign here for a minute, the tangent will be negative, by the way, in quadrant 4 because the cosine is positive and the sine is negative. But if you can think of a quadrant 1 angle, whereas the tangent equals 1, that's at pi over 4. I need to be in quadrant 4, so I need to subtract pi over 4 from 2 pi, which will give me 7 pi over 4. Okay? I have my argument. I have my modulus. And now I can fill in my formula. So this is 6 root 2, that's my r, times cis 7 pi over 4, or cosine 7 pi over 4 plus I sine 7 pi over 4. And I'm done. Right here, I'm done. Let's go backwards. We want to take the trig form of complex number. We want to write it in standard form. Well, this is even simpler going backwards. Why? Because we know what these angles are from our unit circle, okay? And we know what r is. So I need my a and my b. And I know that a is, so remember, a is our cosine theta, b is our sine theta. Now in this case, I don't have to do too much work because I know my r is root 8. And what's even easier is I know what the cosine and the sine of negative pi over 3 are. The cosine of negative pi over 3 is negative 1/2. It's in quadrant 4, right? And the sine of negative pi over 3 is negative root 3/2. And that's also in quadrant 4. So the only other thing I need to do is I need to simplify this radical to 2 root 2. So what I do is the following. I say z is 2 root 2 times 1/2 minus root 3 over 2i. And if I distribute this in, 2 root 2 times 1/2, the 2's will cancel and I'm left with root 2. And when I distribute it to that second term, the 2's will cancel and I'm left with root 2 times root 3. And there's a negative there, is negative root 6i. And I'm done. Here's another one. Oops. Here's the polar form. We want standard form. Well, I know my r is 8, and I know what the cosine and the sine of 2 pi over 3 are. Cosine of 2 pi over 3 is -1/2. This is a quadrant 2 angle. And so the cosine is negative there. And this, of course, is also a quadrant 2 angle, but the sign is positive there. All right, and now all I have to do is distribute my r. So 8 times -1/2 gives me -4. And 8 times √3/2 gives me 4√3. I've gone from trig or polar form to standard form. Okay, so if you have any questions about anything in this video, like I said, it was short and sweet. We're almost wrapping up chapter 6, so we will start to prepare for a review soon and a test, an online lockdown test. I'll give you a mock quiz or test so you can experience what that's like, because it will be timed. But anyway, we're almost done with this, and you go ahead and do this. This was what you were supposed to do on Friday. And again, if you have any questions on the video, if you have any questions with the homework for this topic or in any of the previous ones, please let me know via EDSB. Not anywhere else, just via EDSB. Okay? So you guys have a great day, and I'll talk to you tomorrow.